Hello to everyone. Good day, good morning, or good afternoon. Thank you for attending today's webinar. So my name is Dimitrios Kakogiannis. I'm the Explosion Protection Application Scientist of Fike. Dilip Arulapan, who is the Explosion Protection Consultant, is going to walk you through today through the basics of dust explosions and describe the necessary measurements that need to be taken in order to protect the facility against these explosions. Questions will be answered at the end of the session, and all questions would be answered by email if there is no time to reply to everything. At the end, we will also share a snapshot of the webinar and also the recording. Dilip, the floor is yours.
Yeah, thank you. Thank you, Jimmy. Good afternoon, good morning, everyone. I'm Dilip Arulapan, as Jimmy has introduced. Not to hold on to time, I would like to move on to the content. The main agenda of today is to understand dust explosion and how ATEX EPD it's forming regulations around explosions, and we will focus majorly on dust explosion. Today's content, we will have a short introduction to Fike and history of dust explosions, which you would come across. A couple of accidents happened last year and the year before, and dust explosions conditions and snapshot of ATEX directives. And we will jump onto the main agenda of explosion protection document and how do we conduct a risk assessment under explosion protection document, which is stipulated by ATEX 153 regulations, and then how do we comply with the requirements. As you all know, Fike is an industrial expert and a world leader in explosion protection and suppression and pressure relief techniques and systems. Under explosion protection, we have venting, containment, and suppressions. Obviously, these three will go with isolations. And we also have a team of world experts in technical safety consulting. I'm part of Europe team, serving Europe, Middle East, and Asia Pacific. We do have a wide network of engineers and consultants, scientists based in US. In fire protection, we have detection system and suppression system, and we have area of expertise working on pressure relief side as well. History of dust explosions. So this data indicates accidents that have happened in the past, majority on dust environment, and the survey was conducted by Dust Safety Science, which you could see at the bottom. They are business partners based in Canada. We all know that dust explosions occurs even now and then and everywhere. That the reason behind is lack of engineering or lack of awareness. We could just point out to several reasons. But it is very sad and pivotal for engineers and consultants like us to understand from each near misses and primary explosions, so that we understand from the causes, so that we work on them in preventive measures and also protective measures, so that such deviations leading to explosion could and may not occur in the future. If you're all interested to know more on explosion and incident investigation of these accidents, please drop me a message or email, post webinar, so that we could actually send you a couple of incident investigation performed by Dust Safety Science. What is the intention of ATEX and DESIRE? So today I've only indicated the term ATEX, which stands for AT stands for atmosphere, EX for explosive. We are all aware of that. But what is DESIRE? Since we also have participants from the UK, DESIRE is nothing but dangerous substance and explosive atmosphere, which is, I would say, under HSE, Health Safety Executive Directives. ATEX has been replicated as DESIRE. They both work on the same page, and they are having same coherent focus, controlling any flammable substances, explosive oxidizing properties within the facility or a manufacturing area. Also, DESIRE covers corrosives and compressed gases. So wherever corrosives, pipelines, or materials are stored close proximity to flammables and combustible materials, they have to be reviewed, assessed whether they have been saved or stored appropriately according to the guidelines. Any substances that would create a potential explosive atmosphere. It could be powder, dust, or chemical dust, pharmaceutical dust. Could be a product itself or a byproduct that would be generating an explosive atmosphere. And again, when controlling work activities involving other substances that could create fire and explosion. That's the main focus of ATEX and DESIR. If you ask me, is there a minimum requirement that we have to store or use in a facility to get compliant with ATEX? I would say no, because ATEX is not focusing or pointing out to a certain amount of material. The reason behind that is because, say, if I'm running a plant of an explosive manufacturing TNT, so 1 milligram to 5 milligram of TNT can take an entire roof. So ATEX is not specifying and customizing its regulations focusing on products or facility, but it's a horizontal regulation. So we have to understand where do we stand and how do we customize a solution accordingly. Conditions for explosion. Yeah, I know it is what actually you're visiting, looking at the screen is not a condition for explosion. It is a condition for fire, which is oxygen, fuel, and ignition. The two difference between fire and explosion, obviously, we know that it's mixing within a confinement. Like I said, the conditions for next explosion is the material should be flammable and combustible and should be airborne to form a cloud. How do we know solid materials or powder or dust are flammable or combustible? There are tests. There are tests could be done in laboratory to identify their chemistry and the properties, whether they could be combustible or not, and they should be fine enough to form a cloud within the air atmosphere. They should fall within a concentration explosive limits. It's pretty much same as LFL and UFL, lower flammability level and upper flammability level for vapor and solvents, same concept. Particle size distribution should be capable of propagating flame. How fine is the dust and how fine the flame could propagate according to the particle distribution in an air atmosphere. Obviously, oxygen makes a vital role in an atmosphere, and its combination of oxygen with the dust forms a fuel. We have to manage and maintain the oxygen presence in a closed environment, and obviously must have a sufficient energetic ignition source. It is not just an ignition source, and what energy does ignition source would stipulate to get ignited by dust cloud. We will look into these information in detail in the following slides. Is dust flammable? Like I said, 70 to 80% of organic powders will form flammable atmosphere. Say if I'm working in a food industry and my management have decided to start up a new product line, right? And could be a soup of Mexican flavor. And if they want to introduce such product line and they have to test the product or material they would be procuring, be it from China, could be from India, or could be from Africa or South America. So those material has to be tested according to regulations before even being design has been considered or during design stage. Those testings are called as screening test. When a material goes under a screening test in a laboratory and if material outcome comes as A, which is it could reacted to some form of testing, then material is flammable. If it is non-reactive, it is non-flammable. However, a process engineer or a design engineer should know the in and out of process within your facility that is intended to be used, because some materials which would turn up as a group B, i.e. a non-flammable material, could become a flammable if they undergo highly heated or thermally radiated, or if they go under heavy temperature environment. Say if you're processing a material under oven or fluid bed dryer, yeah, the material can go up to a temperature of about 200 250 degrees Celsius. They could go through different chemical reactions and obviously could become a group A material. So there are possibility and probability where a group B material can become group A. So that's what I could mention in the second point. A/B testings only assess whether the material is flammable or not as a dust cloud. It does not address whether the material is thermally stable. So we have to perform a different testing for them. Like people work in coal industry, thermal stability is a very important parameter. Speaking of flammability data, pardon me, flammability data is nothing but information we would find in a safety data sheet. Same as for gases and vapor, like auto ignition temperature, ignition sensitivity, LFL and UFL, like I mentioned in the previous slide. For dust, it is something called minimum ignition energy. That is the first information that we would like to understand. Minimum ignition temperature, layer ignition temperature, Pmax, KST, ST class. I'm sure that we have a mixed audience here because some of them are familiar to these terminologies, some may not. So I would like to address on a couple of top four datas. MIE is nothing but minimum ignition energy, the energy that would require to ignite a dust cloud, right? But what is the source of these energy? It could be from different sources. It could be from an electrical circuit break, could be from static, could be from a friction, or could be from a foreign body that is mechanical spark. Minimum ignition temperature is nothing but hot surface that is igniting a dust cloud. Layer ignition temperature is nothing but same hot surface igniting layer of dust suspended on top of them. They do have a differences and they do have a equation between each other. MIT and LIT have an equation and relation. The relation between them is as the layer increases, the temperature required to ignite the layer goes down due to insulation effect. Pmax and KST, very important parameter. We will see them in separately in following slides. Minimum explosive concentration, MEC is some. It's like I would say it is a how much dust cloud or how much mixture of fuel, that is dust and oxygen present. But in a practical condition, MEC is only suitable for a closed environment because dust cloud constantly stays in the air and they behave as depends on the air current and movement of air. Limiting oxygen concentration, LOC, is amount of oxygen present or required to reduce the concentration flammability. Burning behavior is how does the material behave? Is it going to extinguish quickly, slower? Does it burn first and then combust second? So this is called burning behavior. Mostly this information is required for pharmaceutical and chemical powder industries. Resistivity, what is how do your material react towards resistance? Charge relaxation time is very important parameter. Once again, charge relaxation time is nothing but data shows that how do your material react to observing an energy, say energy from transferring from point A to point B. If a bulk material is transferred from a tanker into a silo, the material obviously will observe static electricity. And where does material, how long does it take for the material to discharge the energy that is observed? Where the material usually will present inside a silo, maybe in center, on the top, or the side. Thermal stability, like how the material react to the thermal heat. Basically, that's the information. Is majority for coal and pharmaceutical company. So MIE, MI is the lowest spark energy that can ignite optimum mixture of fuel when dispersed in air. Basically, this is done in Hartmann tube. You could see the tube. Usually, the materials are placed here. Could be 5 mg, and then it is actuated by air through this actuator. Air has been dispersed into it, so forming a dust cloud. And we could see here 2 electrode, and there will be a pressure differential created to ignite and to generate a spark. Once a spark is generated, we'll see an explosion, as you can see from here in the photograph. With this, we'll be able to find information of energy that is igniting a dust cloud. So that energy will be taken into a safety data sheet. Using that information, we will see in the following slides how do we prevent ignitions as a part of EPD document. Another parameter is MIT, lower surface temperature that can ignite optimum mixture of fuel. right? MIT is nothing but auto ignition temperature for dust. MIT is used for both establishing the maximum permitted surface temperature of electrical and non-electrical equipment. Even mechanical equipment can become hot and they could give rise to high temperature. This parameter is quite important, 20-liter sphere. This equipment is used to determine Pmax, maximum measured pressure. What is maximum measured pressure? It's nothing but during an explosion. Basically, in laboratory, we will simulate an explosion for a given material in the right amount of conditions, and we would capture those pressure that is generated at the maximum rate. So that is Pmax, and we use this information to design our safety protection equipment. KST, dust constant, that is change of pressure to time. Dust constant change of pressure to time is important parameter because it is nothing but if Pmax is speed and your KST is acceleration, right? In what rate the pressure increases to time. So that's a destructive force, I would say. Explosion severity data, like I mentioned, it is used to design your venting and suppression system and containment. This parameters is used to design and define your basis of safety. And this is quite a common question, and we've been asked whenever we visit site from our clients, how do we understand which is a dust cloud? Is there any right method to establish the dust, this is a dust cloud or this isn't? But there is no set quantitative figure that we could give for an operation that is taken outside a closed room environment. But the thumb rule is if there is a bulb and if you see a dust cloud around it, the bulb should be blurry, and meaning that is a dust cloud, because we cannot define or confine that oxygen presence is X amount and the dust presence, because since the dust might be getting suspended and it might get into a right oxygen atmosphere in that particular condition, if it is get ignited, it could be from static or could be from electrical spark, where from beams and the shop floors we have electrical circuits. That's why you get a primary explosion. Maybe not primary explosion, could be an immerse or a flash fire that could generate and disturb other suspended dust, and then creating a primary explosion, consequently leading to a secondary explosion. So MAC is quite important if the facility is a closed or a clean room, or if it is inside a hopper or a silo. Limiting oxygen concentration, LOC, is a maximum concentration of oxygen mixture dispersed in a combustible air and inert gas, which is an explosion will not occur. This basic phenomena. We all know the oxygen plays a vital role, so there are instrumentations we will just set up to observe what amount of oxygen is required to form a dust cloud, and constantly we'll be monitoring those oxygen so that when the oxygen level goes up, and we use inerting gases to kill the flammable atmosphere. There are thumb rules. If you do not know the LOC value, we could take 5% volume. However, it is best that testing has to be carried out. Before moving to basis of safety, I would like to stop here. Should you all have interest to understand more on this explosibility and ignition sensitivity and severity data, that is Pmax, KST, LIT, MIT, please drop a note to us. We would like to have your feedback so that we could put forward a new webinar on these data and how relevant are these data to your process facilities, because not all data are required for your facility, or sometimes you might be misguided by the Google basics research that if you have a fluid bed dryer, I might need to have ABC information, not necessarily. And how do I test? How do I have to get test? Because we have a material of moisture content, say 92%, but it has been collected into a dust collector. But dust collector in winter behaves different to the dust collector or a dust duct in summer because of temperature and hotness outside the ambient condition. The moisture content may go up to 99 to 100%. What will happen in that scenario? The figures that we discussed here, Pmax and KST, for a situation, let's say you're using, you are part of a as a biosolids, right? Waste generation. You collect all the biosolids from the facility and dump into a warehouse, which would have expected to have 90% dry solids and 10% moisture. That's not the case. During loading and unloading in summer, because of insulation effect and heat on the warehouse roof, the material, that is the dust on the top layer, could become 100% dry. That is Pmax if the pressure is, if you measured pressure for a 90% dried solid, let's say for example is 5 bar, if it is become 100% dry, it could go up to 10 bar. Likewise, KST, which is a destructive force, if it is measured for a 90% dried solid, if the KST value is 20 bar, for 100% or 98 to 100% dry solids, it can go up to 150 bar meter per second, right? That is very important to understand. How do I test and what conditions should I have to test? Likewise, second scenario, your material might be having a size, say, more than 500 microns particle size. Hence, it cannot be flammable. It cannot form a dust cloud. But this may not be the same. This could be different in your dust collector dirty side. If you collect a sample which can go up to 100 microns or 50 microns size, then that property of that dust will be different. So it is very important to understand our management of change within facility and what process our material is going to go through, and have we measured our material every 5-6 years if we have reintroduced new process or increase our production or increased flow or reduced flow, etc., because these will have impact on your particle size. Right. Basis of safety. Basis of safety is nothing but layer of protection. As I listed out: equipment, procedure, deviation, human factors, material properties, and level of risk. Basis of safety is nothing but combination of 1, 2, and 3 to bring us to ensure safety is installed or implemented or achieved by a combination of these three. The three is explosion prevention techniques and avoidance of ignition source techniques and explosion protection techniques. Whatever we are going through now is nothing to do with ATEX regulations. Of course, ATEX is also speaking this, but we are understanding dust explosion, and then we'll apply the same into ATEX regulation, right? Irrespective of ATEX regulations, if we have attendees from Middle East or from India or other part of Asia, also South Americas, I would like to stress this: for dust explosion do have basis of safety, that is 3 preventive measures, ignitions control, and explosion protection. How do we prevent an explosion? Yeah, see, there are many methods to prevent an explosion. As you could see from the figure, like we are monitoring the oxygen presence. As soon as the loop system understands how much oxygen presence, it just kicks in the nitrogen into the system to kill the oxygen level, meaning by it is not letting a fuel and oxygen getting mixed together, forming the right amount of combustible mixture. There are different situations. Even you could work with a basic engineering company, right? And you might be using acetylene for welding. So replacing acetylene to argon is also called explosion preventive measure, because you're replacing your material. But people are working in an industry like food industry, you cannot replace sugar. So what we do, we try to keep our oxygen level, or we would not blow the material. We might do a pneumatic convey. There are several engineering measures and methods that could be applied to avoid formation of dust cloud. Obviously, we could work for gases and vapor. We can work below flammability level, right? And also we can work above flammability level. And second basis of safety is nothing but avoidance of ignition sources. Avoidance of ignition sources is nothing but ensuring that equipments are in place, are maintained accordingly. That is for mechanical sparks. But how do I avoid other ignition sources? That could be from electrical, that could be from static, and that could be from, say, thermal radiation, right? That's why we have come across data. If we have to understand, I'm just skipping. We need to know these data, 1, 2, 3, 4, all the data of a powder or material within our facility, so that we could be able to put forward an engineering measures to avoid ignition sources. So for example, if I have to avoid an ignition that would come from static human, right, that is spark discharge, right, how do I know? Because each material would require certain amount of spark discharge to get ignited. We get tested, and then we would put those measures in place. What measures in place? We just ensure the earthing in place, and there is continuity by there is coupling in place or jumpers in our pipelines. But how many industries are ensuring by resistivity testing? That's number one question, because whenever we go on site, there could be an near miss, and a client might be saying that, well, we had a near miss and we have earthing in place. But first question I will throw at them is, what is a resistivity? What have you? When was the last time you have performed a resistance testing? No answer, right? The resistance testing will ensure that if the material required to achieve 100 millijoule, or sorry, 15 or 12 or 10 per ohms resistance, which would give ignition source if that breaks, then we have to ensure that for our material, for our product, the resistance is achieved according to the measurements that you would do. Likewise, for electrical brake and electrical circuit, we would need to know what is a layer ignition temperature or ignition that would come from electrical spark. Once we have the data, then that will help you to procure or design the right ATEX approved electrical fittings that could be installed in a hazardous area. Hazardous area is another topic that we will come across in the following slides. The third basis of safety is nothing but containment, venting, and suppression. That is explosion protection. So if your first basis of safety, that is preventive measures, has failed, obviously all man-made engineering solutions are failure, because it comes with the failure data according to reliability. And then ignition source, even though you install an ATEX approved electrical equipment, or you have a good MOC or maintenance program in place for mechanical sparks, they could fail because it's all man-made. So we need to have the third basis of safety, which is the final wall, containment, venting, and suppression. If you ask me, can we build a strong containment vessel? What is containment vessel? It's a vessel built strong according to the data, that is P max, because that's the maximum pressure measured, isn't it? So we would design a vessel or a hopper or silo, usually hoppers, that could withstand an explosion pressure if the hopper is expected to be installed inside. Venting is know that we would design a venting according to the Pmax, and so that if the venting goes, we need to achieve a P red, that is reduced pressure, to keep the dust collector or a hopper or any process line safe. Meaning we need to know what is P stat. It is nothing but the pressure at which the vent should open. So if you holding a silo or a hopper dust collector of say starch or sugar, I would say P max, that is maximum pressure of that material, organic material, sugar, could be say 8 to 10 bar, depends on the fineness. And I would size my vent say for 2 bar of 3 bar, depends on my process parameter, because sometimes process delay and process upset could cause increase in pressure, so vent should not go at that time. What is suppression? Suppression is nothing but we would need KST value for suppression mainly, and other Pmax value as well. Suppression is nothing but it's a bottle consists of sodium bicarbonate powder, right, which is stored inside a vessel when a vessel is there. And if there is a pressure buildup inside a vessel, and we have sensors and pressure monitoring sensors, they just quickly act and pass signals to the suppression bottles, and they actuate and then throw like a blanket killing pressure generation. So it's a sorry, it's a precision engineering manufacturing product, because it acts in a fraction of seconds and nanoseconds before the pressure rise, suppression comes out. It's very important to understand that all these three could or should go with the combination of isolation. The reason behind it, even if you have a venting, if there is a dust collector, I can't pick up an example. So if even we have a dust collector, if a vent is if material goes, the pressure goes away from the venting in one direction, obviously the explosion goes in multiple 360 direction. It could go back to the facility where operators or we human could be working. So the duct should be isolated with the slam shut valve or isolation valve. If it is a silo, your rotary valve could act as an isolation if it is ATEX approved. This is it about basis of safety. So just a small recap for the dust conditions of dust explosions, right? What have we come across so far is we understood the conditions of dust explosion. That is, it required air, it required oxygen, it required the material should be flammable. We would be understanding that from basically carrying out testing, whether it's group A or B. Once we know the material is flammable, we have to go forward and identify their other parameters: MIE, LIT, Pmax, KST, minimum ignition energy, minimum ignition temperature, layer ignition temperature. Pmax is measured, maximum measured pressure. KST is change to pressure to time. ST is nothing but severity class. I think I missed to mention that. Apologize. ST class is nothing but severity class, where materials are grouped in three categories: ST1, ST2, ST3. ST1 is nothing but for organic, 2 is chemical and pharmaceutical, 3 is metal. Activated charcoal could fall within these three categories, depends on their moisture content. If I say ST1, sugar, starch, pharma, paprika, any organic materials are the weakest amongst all the three. ST3, that is metal dust, is quite explosive in terms of severity, meaning their Pmax values are massive. Right, now we are moving on to ATEX regulations. There are two regulations. ATEX has been regulated and they provided to the European Union. One is for plant and second is for equipment. Plant safety regulations, nothing but directed toward the facility owners, employers, to ensure workers' exposure to fire and explosions hazards are minimized, and generally address operations, facility, and building construction. And equipment regulation is towards facility owners, manufacturers of equipments that are intended to be designed that will be installed in an explosive atmosphere or flammable atmosphere. Each independent city, country, state, national has their own legal regulations by self-creation and many adoption of their authority bodies. Likewise, France and UK and other Germany, they have observed ATEX regulations, and they have made their own regulations as well. But all the European states and states member have to oblige ATEX regulations. So let's look into these two regulations. Work directive, right? Like I said, it's aimed to keep the workplace safe. Product directives 2014-34 EU regulation 114. You might come across different numbers, like instead of 153 you would come across 137. Instead of ATEX 114 for equipment you could come across 97. So these are all the oldest regulations, and they've been amended and given more detail to the standards to make employers and the countries to observe more simplified. The reason behind ATEX in 1999, they started to putting together 98, is to allow a free trade between all the European Unions, states within European Unions. That is, any electrical equipment that manufactured that is intended to use in flammable atmosphere, specifically chemical industry, they have to follow certain code of manufacturing codes and principle. And then it's electrical installation alone cannot, basically keep us safe. So there are certain principles has been imposed and recommended by the directive EU Commission that manufacturers of facility owners and facility employers have to follow to keep the plant safe. What are they? So there are some examples listed here. USA use NFPA, and European Union, we use European Electrical Committee, which is basically they put standards to comply for ATEX regulations. UK, we have HSE, Health, Safety and Executive, and then they also observe ATEX as one of their standards. German, they have their own standard VDI. It's pretty much is used for suppression and explosion category VDI regulations. Here in ATEX directive, how it has been carried out is by EPD method, explosion protection document method. And in the UK, DSEAR, dangerous substance explosive atmosphere regulations, that is part of COSH as well. And in USA, DHA, dust hazard analysis, is a risk assessment method performed to understand and deviation of risk and risk assessment. And here in equipment category, equipment explosions safety requirements for electrical mechanical through all member of states is brought by 2014 114 amendments. There's a snapshot of regulations, and you should get a snapshot of entire webinar content post this webinar. So I would remember to include a couple of regulations to keep in mind. EPD, explosion protection document. EPD is nothing but a set of document which will include your material information, your process information, PNID, process description, and what are the process parameters, management of change history of incidents and accidents, the material you manufacture or material you procure or byproduct of your process, and the data, that is the data which we have seen, that is MIT, LIT, those parameters, their reactivity, their nature, everything should be recorded. And then a risk assessment should be formally carried out by an expert. It could be in-house or it could be external. And those risk assessments should be recorded, and action plan, training employees on ATEX, equipment information, what are the equipments are installed on the areas, hazardous areas. We will see, we'll come across a hazardous area section, a couple of slides. Sorry. What is an explosion protection document? Like I explained, I'm going to read out what is mentioned on the regulation. ATEX Directive 1999/92 EC requires employers who have process or buildings in which explosive atmosphere can arise to perform a risk analysis to demonstrate compliance by completing a formal documented risk assessment. So we have to do a complete thorough risk assessment. Say, I know that I'm using 1 liter of a flammable material, right? And if you come and ask me, look, you're using 1 liter of flammable, or I'm using 1 liter material, or half a liter of material, do I have to comply with ATEX regulation? I would say yes. Then might ask me, do I have to replace all the electricals? I would say no, because the point is that we have to understand ATEX is stressing one point, that you have to include all the areas of your facility in order to exclude them as non-hazardous. That is, we need to have a basic evidence. How am I stating or concluding that area is non-hazardous? Say, if I have 0.5 ml of material which is flammable, but however it is stored in a cabinet and the vapor is not going to go anywhere because I have a duct extraction, or it's a flammable duct extraction cabinet, and meaning that area is only expected to be kept close. So it is only a small portion of area is hazardous, not my entire site. But still, all the areas has to be assessed in order to exclude them as a non-hazardous area. So all the area has to be included, recorded, and mentioned in the EPD document. Sometimes if you have come across EPDs where they would only include the areas or wouldn't be captured the areas where flammable dust are stored, but they would miss the corrosives. Or sometimes they will include corrosives, but they will miss compressed gases. So we have to think in a bigger picture, that have we assessed all the areas. What EPD must include? It should include explosion risk have been determined and assessed, like I said. technical measures should put in place to reduce explosion, measures used to lessen the effect of explosion, operations measures that would give early warnings like alarms and controls, signals, classified places where explosions may occur called hazardous zones. It's very important. We will see that in following slides. Hazardous area zones. Training to employees, because everybody should be made aware of um, explosive atmosphere and the process and what the materials you are being exposed to dealt with. Operations of permit to work, properties of substance, which we have already seen, properties, data, explosivity, explosive indices, and flammability properties all are just pointing out to the same information that we have come across: MIE, MIT, LIT, PMAX, KST, that data for dust. And is there any means of escape and evacuation escape procedure in place if any incidents can occur? How do we know if an incident can occur? Of course, obviously by risk assessment and consequence analysis, if you're using a massive storage of gases or ammonia, etc. When do you have to review an EPD? Basic question. Whenever there is a management of change, it has to be updated, amended, and reviewed, and then documented. So if you could see, we have two symbols, right? There are two different meanings for these symbols. This you will come across in an equipment, ATEX equipment, meaning this is approved by ATEX. And this is for the area where hazardous materials are stored or explosive atmosphere may occur. This is quite important term, may occur. That is, your may occur could be different to my may occur. So it is always wise to have a different viewpoint in terms of, should be the hazardous area team and the risk assessment team of EPD within a facility should be a cross-sectional team, could be a mix of electrical engineers, instrumentation, safety, process, and operators. They are very important part of a team, because they would be able to show us information where the deviations are generally occurring. So the explosive atmosphere may occur is very important. Fire and explosion characteristics of material. We have already seen this, right? What are the characteristics of material? For vapors and gases, these information we would find in safety data sheet, flash point, boiling point, vapor pressure, MEC, upper explosive level, minimum ignition energy. Minimum ignition energy principle is same for vapor, gas, and dust, and T-class and gas group. Since we are focusing on dust, I'll skip to the next slide. Here, this is how a basic risk assessment template will look like this is how we capture the information. Explosion pressure, KST, concentration, minimum ignition energy. I think this minimum ignition energy is very good, because in the sense it's bigger than 1000 millijoule. If I say human could store a minimum ignition energy of 30 millijoule, meaning we could store up to 30 millijoule. And what happened if we stored more than that? That's why when you go and touch the door, we get a shock. The reason behind that is we cannot store more than that energy, so we tend to pass it to Earth's conductor. We will be able, human could actually can ignite a dust cloud of sugar if it's not appropriately earthed. And we would say our shoes are basically anti-static. We might have anti-static shoe, but it is silly that we might walk on a painted floor, right? So, which is an insulator, obviously. So it's quite important to understand 3-point connection of static, how we are measuring, and whether it is, are we being actually earthed. I'm sorry. Minimum ignition temperature, another data that we understood, and like I said, this is important. That is combustible content and how dryness is the material is actually. Oops. Once again, explosibility testing data. This is very important for EPD. Informations on material properties and explosiveness should be recorded. The recent regulations in UK and Europe, REACH regulations, what it indicated in 2021 is any supplier of these materials should perform testing by themselves and stipulate all the information into a safety data sheet and pass on to the manufacturer. So if you have those information with you as a material come into your facility as a part of your asset register is good. If not, it becomes your liability to perform testing, to record, to make EPD a document. Hazardous area classification. What is hazardous area? Hazardous area is nothing but an area that is expected to be hazardous in different conditions, in continuous operation, a part of normal operation, or a deviation, right? And EPDs enforcing employers to perform a hazardous area classification, record them. The reason is that in this area only we will be able to look for, or we will be focusing what are the ignition sources that present, the ignition sources that presents that we might have to put measures to avoid them, or to protect the ignition that comes in contact with an explosive atmosphere. Like I said, the triangle with EX indicates the areas is expected to have flammable or explosive atmosphere may occur. Hazardous area is classified into 3 categories: zone 0, 1, 2 for gas and vapor, and for dust it is same concept, 20, 21, 22. It's nothing but when a material is present continuously in an area is 20, and if it is present during normal operation is 21, and if it is present during deviation or secondary release around like failure of a back filter, failure of flanges, that could be a material, or if an operator is tipping a material of 25 kg of sugar into a mixer and it is expected to have a dust around the mixer and around the tipping station, but if it's accidentally fall down, there could be a dust cloud, which is on 22. Another example is, we all know dust collector has the 2 segments, clean and dirty side, but the honest question is that, can you ensure that your clean side of your dust collector is always clean? No. I mean, I never come across personally a clean side to be a clean side dirty dust collector. The reason behind is either the material is different to what it has been actually designed for. Maybe a sugar or the dust could be expected to be 200 mil, but now the dust is actually become 100 mil. That's why it passes through the cleanup media, filter media. So your clean side is basically become dirty side. So according to design, your clean side of the dust collector should be zone 22 because it's accidental release, but due to process deviation or improper maintenance or incorrect dust filters, if constantly your clean side is expected to have a dust, it becomes zone 21. The reason behind that is there are some duration numerical calculations behind this. ATEX EN 60079 gives you this numbers. Continuous means materials present inside a silo, hopper, or dust collectors dirty side. We could continuously see more than 1,000 hours, right? So inside an equipment, and likely to occur is nothing but normal operation, that is within your duct line, rotary valve, screw conveyor. Depends if your process is batch process or continuous process, and not likely to occur, meaning the standard is ATEX is expecting us to keep our facility clean and to have a good maintenance program that all of his equipment joints are according to the design standard and installation guidelines. That is, even if there is a leak, we would address them, and there won't be a leak more than 10 hours. I don't see that. I mean, it's always zone 21, but we could ensure that is zone 22 by improving our housekeeping. A basic zoning will look like this, like manual discharge, like I said, part of discharging, because this is part of operation. You expect to see a dust cloud, irrespective to you have there is an extraction on the top or not. So dust zone 21, maybe 0.5 meter to 1 meter, depends on the particle size. And inside a hopper, feed hopper, continuously present. So it's zone 20, and product discharge here is zone 20, continuously present. and zone 22 around there because dust is fugitive. It just stays in the air for a long time, right? And it's unexpected. So zone 22. What to do with these different zones? We have multiple zones now. We have 20, 21, and 22. And that this will help you to put your risk assessment level high or low, and then to ensure to give you a map. If you look at this facility, it will this layout. Um, this will help you to understand how big is my hazard, how big is my risk, where do I have to install ATEX equipment, right? In this area, if you have any like levels or any pressure gauge installed inside, it should be rated for zone 20. Rated means design according to ATEX standard for zone 20. And equipment installed will be for zone 22, and here will be for zone 21 or zone 22. For the safety reasons, it's best we install for zone 21. Ignition risk assessment. We have to perform an ignition risk assessment to avoid them, to control them, right? How do we perform? So we need to first of all identify an ignition list of ignition source that is present. So ATEX standard EN 1127 gives you 13 types of ignition source, right? Out of 13, we can pick and choose the top 5 or 6 for according to our process, and then we list out which are the ignition sources are relevant to our process, and then do we have data, do we have measures to control them. Likewise, we will be able to control and identify and prevent or eliminate basically ignition source. Bear in mind, all the ignition source assessment should be performed within a hazardous area or where expected to occur, not in canteen, not in admin building, not in an area where you have offices in your process flow. No, all this ignition source risk assessment has to be performed in hazardous area zones because the recommendation implementation is expensive, i.e. installation of ATEX electrical equipment. Yes, like I said, we have 13 types of ignition sources, hot surfaces. So if I ask you what data that we need to mitigate or avoid hot surfaces means, which is MIT and LIT and electrical and static, etc. Mechanical spark, and mechanical sparks are controlled by I would say the management of change programs and highly effective preventive maintenance. We all know frictional and heat and hot work. Frictional heat can be generated by materials, yes. So again, mechanical maintenance is only a solution to control the mechanical spark. Electrical equipment. So dry electrics, electric arcs, overheating. Electrical equipments require two data as MIT LIT, that is temperature, and ignition source from spark. These two parameters has to be considered before selecting or choosing an electrical equipment that would be installed in a hazardous area. Underrated electrical equipment in a dusty environment. I could see these electrical equipments are not rated according to ATEX, and housekeeping programs according to EN standard is not in place. Open flames and hot surfaces like these hanging fixtures and boiler area, these are also a type of ignition source. Static electricity is very important to understand. Spark discharge, bulk discharge, cone discharge. There are several types of static. There are even corona discharges there and propagating brush discharges there. If you're interested to know just alone on the static side, please drop us a message or email, and we would consider to put forward a webinar in ignition risk assessment alone. Like I said, if you see an operator can hold up to 30 millijoule here of static electricity. So if we walk into a dust cloud of pharma or chemical or metal dust or even sugar or starch, and then we would be potentially igniting them. Consequence has to be considered, right? What are the safe operating measures has to be taken, and then what type of equipments and occupants in near location we have to look into fact while we're performing a risk assessment. We have to evaluate the risk by likelihood of ignition and what is the severity level by risk assessment and ranking. So this is basically a Fike risk assessment, and we do have 5 types to separate them into group them: acceptable, tolerable, and desirable. According to this, our recommendation priority will be listed out, and we would advise our client which one to look at first. What to do using the explosion risk assessment? Explosion risk assessment results? Of course, the aim is to control an explosion, or to avoid them from occurring, to minimize their risk, and prioritize the preventive measures first, rather than installation of equipments that do just to protect. In order to mitigate the explosion hazards, housekeeping, I would say, is very important, and that is an administrative control, engineering control, preventive measures, right? We need to understand preventive measures. There are recognized and accepted engineering measures across the countries, and ICME is a standard if you all would like to pick up an accepted engineering practice. CCPS also have a massive guidelines in that. Ignition source reduction and deflagration explosion protection. If you look at these, this is basis of safety. Number 1, preventive, explosion prevention, avoidance of ignition source, and explosion protection. ATEX equipment categories, right? There are category 1 and 2, and how to use them and identify them right here. Category 1 is high level protection, and normal level protection. Sorry, very high level, and normal level protection. Roman number 2, which classifies what surface are they, what industries are they, and G for gas or dust, and number determines whether it's M1 or M2, that is overground or underground mining industry or surface industry. Explosive protected with the protection concept, flame proof, intrinsically safe, etc. IA is not, I means intrinsically safe, whether material is the equipment will stand 1 failure or 2 failure. IA means equipment can withstand 2 failure, that is, then this has to be installed in zone 0 or zone 20. Gas group, we could say, and T4 is a temperature class, meaning how much temperature the surface will let the surface of the equipment could go up to. So this information we can depict from AIT for gas and vapor, and MIT LIT for dust. This last is very important to understand according to the zone. This is GA, GB, GC, that is gas, same concept, DA, DB, DC, dust. This is for zone 20, high level, very high level 20, 0, 1, and 21. DC is nothing but for zone 22 or zone 2. Training, it is very important for the employers to ensure training has been implemented, or awareness on ATEX, or been horizontally imparted to engineer level to the ground level, and an ATEX concept and EPD document should be shared amongst all employees. The training should include whatever we have come across so far. The training has to capture everything in detail and be shared within employees. All the informations of EPD should be written and recorded, and that has to be part of your work permit, because hazardous area classification should include to be a part of your work permit, which will let an external contractor to identify whether to make an hard work or not in zones. EPD review, like I said, should be kept up to date. If there is a management of change, it has to be reviewed, recorded, amended, and then it should be made as a control document. Thank you, everyone. I know it's been a lot of information in a short spell, right? And I hope you all enjoyed this webinar, and I could see there are a couple of questions here. And let me see. Some oil and gas questions are here. 1 second. We could see several questions being asked, and what we do is we will try to answer what is the KST of Bmax for TNT. Right, so we have to look at the library of Fike, and we will be then able to answer for TNT. I'm sure KST should be more than 200 or 300 bar meter per second. Somebody is asking, worked in how do we define outside equipment internals. So William, I would answer this email via answer via email. But in short note, we have to understand the process and process parameter. Only then we'll be able to identify the zones. So thank you everyone for your participation, and you should receive a snapshot of the webinar content. And should you have any interesting topics for the future, please do not hesitate to contact us. We'll be happy to take that into consideration for our next webinar. Thank you. Have a good day.